You just found the CNC Tech YouTube channel.
Alright, so what I have here is a Mr. Heater, Big Buddy heater. Works really well. It's the yellow version that was available at Lowe's. I decided to start making a couple videos of the little projects and things that I get into. So if you like it, like and share and ring the bell on the YouTube video, and if I get enough response I'll make some more. So anyway, this Big Buddy comes with a fan that's run by this switch here. I don't know if you can see that right there. Well, it hasn't worked since it was brand new. I've contacted the manufacturer. They've since discontinued putting the fan in these heaters, and replacement parts, if available, don't work any better. So I had some thoughts on how to fix it, and that's what I'm going to go through now, is do those modifications and see what happens. This fan either worked by 4 AA or C-cell batteries, or you could use plug it in with a 5 to 6 volt DC power supply. Now I've already tested this fan in the unit with a variable DC power supply to eliminate the switch, the wiring, anything supplied in the unit, to isolate it to the fan. So to dig into the fan, you got to remove the back cover, take the 4 Phillips screws out, and to get this off, you pull up from the bottom, and there's some tabs in here that get caught. You have to pull up and back towards you, and it'll slide open. Then there's some pins up here at the top that you have to slide it off of. So you push forward and it'll slide out from underneath the handle. This is your heater. We're going to set that aside. This is the back panel with the fan motor. Basically, when you energize the fan motor, it locks it into position. Nothing I've done will get it to run. There's 4 screws in the sheet metal cover that are 3 times longer than they need to be. But I guess that's okay going into plastic. We're going to use this later, probably with some modification, maybe have to replace it, but we'll see. Sit down here. We're going to zoom in a little bit. So to get this fan out, there's 3 holes in the fan that line up with screws in the base plate. magnetism of the motor will probably pull the screws off of your screwdriver. I'm using a magnetic tip screwdriver, but they still don't like to come out past the motor. Unplug this little cable here and pull the old fan motor out. This is just a little DC brushless motor, squirrel cage type fan. So my idea, as I often do and lay in bed and figure out how to solve these problems at night, is to replace it with another DC brushless fan, but this time it's fully enclosed. I don't know if you can read the information. I'll try to put a link to the fan and the parts that I use in the description if everything works. So my thought is we're just going to mount this fan to the mounting plate so that the discharge lines up with the channel. And all this fan really does is moves air across the top of the heater, because convection has the heat rising out of the heater, and this just helps move the heat and distribute a bit more evenly. The problem I see is with this cover plate, for the inlet to be right, this has to be centered on the old fan, and unfortunately the rotation of this housing, and I couldn't find an opposite rotation housing easily, puts the discharge away from the duct for the airflow. So we're going to have to be offset. There's no interferences in the heater, I don't think, that would cause this to be a problem, but it's going to interfere with our mounting posts for the heat shield and the inlet hole in the heat shield. So we'll have to address that as I move forward. I'm going to pause here, double check for interferences in the heater, and be back. Alright, so inside the back of the heater, there's a cavity that the fan and the battery box sits in. This is where we would have an interference with offsetting the fan to one side. So it looks like, measuring from where the cover sits, we're about 1 3/16 inches on that side, about 1 1/4 inches on that side. So what I'm going to do is take a Sharpie. I'm going to measure over 1 3/8 inches from the edge and give myself a reference line. We're going to set the new fan in, keeping it inside that 1 3/8 inches mark. And it looks like we've got good alignment with the channel for the airflow. So I'm going to make some marks on these channel walls, because we're going to have to do some trimming. Looks like I get to keep a post to hold the deflector in, so that'll be good, and maybe we can use one of these other mounting holes for that deflector. So we're going to have to remove basically this whole channel over to here and to here and to here. I don't know if you can see that. There's my guide marks, and there's what we're going to remove here and all through here. Okay, so to remove this, I'm going to use my Dremel tool with an abrasive wheel on the end. This is a variable speed. I'm going to run it fairly low so I don't just melt everything, although that's how it's going to work out. I zoomed out a little bit so I can move around and you can see kind of what I've got going on. I'm going to cut a little bit short so that I can come back and trim it more double check that we're getting close to where we want. Yeah, I get that cleaned up and I think we'll be looking pretty good. I'm going to get a different tool. Be back. Now this is going to get a little bit louder. I'm going to use an air die grinder, right angle. This is just one from Harbor Freight. I'm going to use a 40 grit roll lock disc. I find on plastic, you know, a really coarse grit will grind and cut a little better, keep itself clean without packing up and clogging the disc. Give me 1 second and I'll be right back with another little tip. Candle wax. You can use this to lubricate the disc and it'll also help keep the disc from packing up. This is a good tip when you're grinding soft materials, plastic, bronze, brass, aluminum, those types of things. Your discs will last a lot longer. This is going to get a little bit louder than the Dremel, but you know, it's the better tool. Just grind some wax on it. I'm going to go in and clean this up a bit. So you can see I got the shop vac out and cleaned up a little bit before coming back. Makes a heck of a mess. But you can see I removed all those areas I marked. Got it down to the back plate. Gonna clean up a couple of these edges just to get the flash off from the grinding. When you're cleaning up plastic, you don't always have to cut or sand. You can just scrape the edges similar to deburring steel and it'll clean right up. Alright, let's see how we fit. Alright. We're good with our alignment marks over here. I think we need to move forward a little bit to get our air trough lined up. I left this just a little bit short. I don't know if you can see that silver mark still there, just to make sure we didn't have any clearance issues. I may have to clearance back here in the back a little bit. Let me get that taken care of. Looking pretty good. So now we gotta get this mounted in here permanently. You have to excuse me, this is actually my very first video, so working backwards from the camera is a little difficult. I think what we're going to do is just go straight through the mounting holes that are provided in the corners, 3 quarters of the fan, and that's, I think, going to hold us just fine. The fan came with some mounting hardware in the box. Not sure it's long enough, but we're gonna give it a go. Let me find some drill bits in the drill and I'll... Alright, so got my drill. This ends up being a 5/32 drill bit. We're gonna hold this in place. Look at that, we're not even gonna hurt any of the warning and instruction information. I don't know if you can see these screws. See if it focuses here. Well, anyway, they are countersunk screws. So I'm going to get my countersink bit. Countersink bit. And we're just gonna clean up these holes a little bit. So that the screw heads sit somewhat flush in this kind of deburrs the holes a bit. Let's see. Looks like we might be long enough. These screws were not made for these paws. So that screw's not long enough, and what I see is for the thumb recess right here for the battery door, I've got a little bit of an interference here. So I am going to pull this back off, clearance that a little bit so it sits down flush, and I'll be right back with you. So what I ended up doing, I don't know if you can see this, is I clearanced the fan a little bit, because if I would have ground any more on this bubble, I would have cut through here, and I didn't want it to look like that. So I think this is going to get us where we need to be. Oh yeah, good luck with these hands. So I did go get a nut driver to work with, since my fingers are not made for this job. Once this is all good and I'm happy with it, I will pull these back out, put some keep it tight liquid on it, Loctite, or whatever brand you prefer. So it's dismounted. Doesn't look too bad on the back side. Most people probably wouldn't even notice. There's a modification. So, tuck this wire out of harm's way. Maybe. And let's see if we have a fit. So you put this in the opposite way you took it out. Push it in so that the pins drop over. Then you have to pull it. Drops in, and I'll be. I think we have a fit. I always hate when you have to pull this hard. Alright. Now we'll continue. In fact, hang on. I'll be back. I'm going to clean up a little bit. So one of the reasons I bought the particular fan that I did is it came with this variable speed power supply, on-off switch, and it varies the voltage from, I believe, 4 to 12 volts to vary the speed. Well, the unit itself has 4 D cells, which is a 6-volt system, which should run this fan, you know, just under half speed when you're running on battery power. And when you work it with the external 110 power supply, you can get a lot more air movement when you're, you know, in a position to be able to plug it into the outlet or a generator or something. Well, I'm trying a different camera here. The other one's charging. I guess I got to get some more batteries if I'm going to do this thing. But anyway, just looking at the shield and how I'm going to have to modify that. Back to where we were with the electronics. I'm going to tie into the existing harness here. This fan came with a 5-volt DC plug. I happen to have some of those from other projects. So I'm going to try to tie this all in so that the battery pack, the D cells still work, as well as the plug for the the speed control. I took the existing plug out of its hole. I'm going to enlarge this receiver to enlarge this hole so that this is mounted in the back panel, and see how that works. So let's see, what size do we have here? So we got 0.448. Let me see if I have a bit and we'll go from there. Unfortunately, from here on, the GoPro didn't record any audio. I'm going to attempt to narrate over top and get through to the end of the video. Sorry for the trouble. I went and found a 29/64 drill bit and was ready to go until I decided that I wanted to try a different route. Sharp twist drills and plastic don't mix. They can grab and cause damage and not make a very good hole. So I went and found my step drill. They're less aggressive and will get us closer without the potential for damage. Here's another small helpful tip. I use a piece of masking tape, duct tape, whatever you have, and wrap it around the bit at the correct step level or size that you want to drill. Keeps you from having to count the steps as you drill down through and gives you a good visual reference of where to stop to get the right size hole. I also go very slow with these bits in plastic. Slower's safer, get you to the right point without a lot of damage. I also, on my drill, and like most new drills, these have a clutch adjustment, and I try to keep that clutch set as loose as possible so that if the bit does grab, it doesn't pull the part out of your hand or rip the hole out around. And again, slower gets you there without the potential for damage. Once I got to the 7/16 step on the step drill, it was time to change over to the 29/64 bit. Again, with the clutch set really loose, I went on to enlarge this hole. You can see the bit isn't turning very fast. In fact, it wasn't turning at all at the start. That's how sharp the bit is grabbing the plastic. But it finally made about a revolution and a half. And then I put the drill in reverse. Not sure if you can tell on the video. And that basically breaks those chips off and reams the hole to the right size. Test fit the plug and it worked. So I flipped it over, put it in from the back, and you can see that it turned out to be a pretty nice fit. Time to move on and address the wiring. Like I said at the beginning of the video, this unit originally was powered by batteries and a 5-volt DC plug. So we're going to try to wire that in the same way. The green and white wires on here are positive, the black wires are negative. The motor does have a red wire on it that hooks into the green and white. So first we're going to tie a plug into the motor wires, hooking red to red, black to black, stripping the wires here. I'm going to use butt connectors in this situation. Low voltage, low current. Maybe later I will solder these connections, but honestly speaking, I ran out of solder and haven't gotten any yet. So I think this will do well to test and get things going. It's always good to use wire strippers to avoid damaging the strands inside the installation when you're stripping the insulation. Also, twisting the strands before applying the butt connector helps make for a good joint. And then I'm using channel lock crimpers here. They're specifically designed for crimp type connections that give you a very consistent, good crimp. When you're doing crimp connector connections, I always like to do a little tug on the connector after I make the crimp, just to make sure you have a good bite, as you can see me doing here in the video. If you're going to be exposing these joints to moisture or anything like that, there are other types of connectors that have a sealant built into them so that when you make the connection it becomes watertight. The other good idea is, if you have a lot of vibration and so forth happening, is to add shrink tubing over top of the connector out onto the wire on both sides, and that gives you a good strain relief connection on these wires. In this case, this is really a test to make sure everything's good. I'll tidy up the wiring and do some more permanent work later on after I make sure everything works as it's supposed to. Now that the motor plug is wired, we'll move on to the power supply wiring. As I said, green and white on here were positive, black is negative. So I'm going to tie both the green and white together and connect that to the red of the female plug I mounted in the back panel of the heater. And then I will tie the black grounds together and hook those with a butt connector to the black wire on the plug in the back of the heater. Now that all those connections are made, it's time for the payoff. Or at least I hope so. We're going to grab the speed controller on-off switch, get it plugged in, plug it into the socket in the back panel of the heater. We'll see if we get power and check rotation of the fan. This is where the lack of sound on the video is really disappointing. We had success on the first shot. The fan started right up. It was blowing the correct direction. As you can see here, I used this piece of cardboard to show that it is drawing air in the center of the squirrel cage and blowing it out the discharge as it should. The speed controller is working, increasing the speed of the blower, and here I'm testing the switch on the panel of the heater itself to check for on-off, and it also works. The next step was to test the system with batteries. Since there's no sound in the video, there wasn't much to see other than to say the impressive part was that I actually found 4 D cells and the result was good. So it's time to get everything put back together. So what I'm going to do here is get the plug epoxied into the back cover. I'm going to put Loctite on the nuts for the screws retaining the fan. I'm going to clean up some of the wiring and then move on to getting the heat shield taken care of. As you can see there, I'm using Loctite 271, which is a red permanent strength Loctite. Normally I would use blue 242, I believe, which is removable strength, but in this case the fasteners are so small, shouldn't be any problem getting them back apart, and you know, this is what I had on hand at the time. I'm going to secure the female plug in the back of the heater panel. I'm going to use JB Weld clear 5-minute epoxy, part A, part B, like most 5-minute epoxies. I usually use whatever I have laying around as a mixing palette. This is the package from the D-cell batteries that I amazingly found. When I mix, I don't put everything in one puddle out of the bottles. I make 2 dots next to each other. I make the dots the same size. It's a good way of estimating your proportions for 1-to-1. I'll then use a craft stick to mix them together. As you mix, it'll become a cloudy white color. Once you get a uniform cloudy white color, mix another few seconds to make sure you're completely blended, and then apply it to your part. In this case, I'm going to apply it like a fillet around the plug and back panel just to secure that slip fit. There really wasn't much to see with me applying the epoxy with the craft stick. It was hard to show on the camera. Hopefully you can see the shiny epoxy around the plug. I let that sit for about 10-15 minutes, went and got myself something to drink, came back and started to clean up the wires, added some zip ties to hold everything together, keep everything under the heat shield and air duct panel, which is the next panel that we're going to address. Early in the video, I mentioned that the hole is not in the correct place for the current location of the new fan. So I lined that up. I used a roll of masking tape you can see by my left hand. It was about the right size for the fan that I installed. I centered that masking tape over the inlet of the new fan, used a Sharpie to trace that out, and now I'm going to use some tin snips to cut that hole and create a better inlet in that panel. I got the panel mounted, tested the fan, and everything worked really well. If you remember early in the video, I mentioned that I removed one of the screw posts and there was only going to be 3 screws holding the heat shield deflector panel in. I decided I didn't like that, and I'm going to use one of the empty holes in the fan that was in the upper right hand corner there to secure that panel. To do that, I have to fill that hole with 5-minute epoxy because it's too large for the screws that are provided with the panel. So I'll mix some of that up. I'll fill the hole with epoxy. I'll put some balled up masking tape in the bottom of that hole so I don't have to fill the hole completely. I'll then coat the screw with some tri-flow silicone lubricant and put the screw down in the hole in the liquid 5-minute epoxy. I'll use some tape to hold that down and let the epoxy cure. Once the epoxy cures, the oil, the silicone lubricant, will allow me to back that screw out and have threads created in that hole and allow that panel to be secured. Now that I've had some lunch and let the epoxy cure for about 45 minutes, we'll pull the tape off and see if we can get the screw out and see if we're successful. Looks like we have good retention. Screws coming out as expected. And we'll put it back in. This little trick is good for repairing any kind of plastic parts with stripped screws or cracked bosses. Really works well. Now it's time to put the heater back together and take a look and make sure everything works well. Everything's back together. Everything fits well. No interferences. The screws holding the fan don't even bother the writing on the back of the unit. The plug I installed looks factory as it would have come from the manufacturer. And yeah, looks like exactly how I hoped it would come out. Hope everybody liked the video. I know it's a little long, but I wanted to go in detail to show how everything was done. It's also my first video, so I'm just learning how to edit and add voiceovers and music and so forth. So if you like the content, like, subscribe, ring the bell, share, and I'll try to show you some more of the projects I get into as I find something interesting. Leave any comments, questions below, and I'll try to answer any questions you may have. Thanks for checking out CNC Tech's Garage.